Hi. So we are going to proceed from where we stopped. Last class, we treated a topic which is Seaborn modules. Seaborn, very flexible package that is used to complement Matplotlib for visualization to draw different kinds of map. You can scale it, you can customize it to any aspect you want. It has a lot of inbuilt visualization charts there. So today we are going to apply that Seaborn in what we're going to do. So if you have not watched the previous video, please do so. Now we want to look at what's called normal distribution. So normal distribution is what we want to look at today. I'm going to just comment it. Let me just say normal distribution. So it's popularly used in statistics and possibly economics, econometrics like that. So this is normal distribution. Okay. Now let's move straight. The first thing I want to do is to import. Please permit me. I'm going to import NumPy as NP, and then import what? So from NumPy now we're going to import random. From NumPy, remember we have done random before. From NumPy, import what? Random. Okay. Then we are going to draw built-in Seaborn. So first of all, Seaborn is built on top of Matplotlib, as I've said before in the previous class. So from import what? Matplotlib. Matplotlib dot pyplot, that plotting package there. Matplotlib pyplot as what? PLT. Okay, then import Seaborn now. Import Seaborn. Seaborn as what? SNS, please. Yes, sir. So I just want to import on the package so that we don't need to import the package again. We just continue, because we're going to need virtually almost all the packages here right now. What is the next line of action? So let me walk you through the let me just run it and walk you through the next option now, which is up is code. I think it's in code. Okay, so the next line of action is let's use the random and see, and generate a random text, but it's going to be conforming to normal distribution kind of values. You understand? So let us look at it. So let me just say random. So random now dot number. So it's to generate a normal distribution of sets of numbers. So the first thing when I talked about this, I talked about size. So you can define the size. Say, okay, the size of numbers, let me just say 10 different sizes. 10 different numbers randomly distributed. So let me equate it to x. Let me just give you several options and see. Then print the x and see what it gives you. Print x, and what does x gives you? X is going to give you something. Oh, sorry, what is the issue there? Oh, sorry. Size equals to 10. There's no double stuff here. So we have about 10 values. So you can also make it like this. Let me just say y equals to. So let me just generate others again, like it's just a refreshing the recap of what we have done before. Normal. Okay, so I want a two-dimensional arrangement now. So I equate it to let me just say 2 by 3. So it's going to have 2 rows and 3 columns. So let me work it out and print y now. Print y. So you see now when I say print y, so it's going to let me just run that. So you see now. So this, how many dimensions? About 2 by 3. That is 2 dimensions now. Okay, that is for the numbers. Now I want to go to, sometimes when you have a random, normal distribution actually in statistics is also called Gaussian distribution. It's named after Friedrich Gauss, a German. So it's used popularly to, sometimes you want to know how values are distributed across a mean. When you have a mean, you have standard deviation. It deviates from the mean to how the curve. So the curve we are going to generate, it's called bell curve or normal curve. It's also called bell curve because it looks like a bell shape. You understand? Like a bell you ring. You understand? So that is it. So the first thing is that we have learned how to generate normal sets of values. Okay, what if we want it to have a mean, want to specify a mean, want to specify standard deviation, then the size. So let me just show you that. So I will do it in addition to these other ones. So initially, we have x. Let me just print x and see what it gives me. So this is what we have about x, just 10 values. Okay, now I want to say give it a mean. So in this case, now let me just have a comment here right now. Sorry, the comment. So in this case, we want to specify a mean of what? Let's say a mean of 1. Go and read about normal curve. Normal curve has the middle point, that's where the mean lies, and then the other part that is away from the mean, which where the shape goes down, it's called your deviations or standard deviations there. So you have the mean, you have the standard deviation, okay, and then you can talk about the size. After that, you can talk about the size of the curve, all of the curves, okay, of the curve line. So the first thing is this: I want to just generate values now based on these parameters, not just based on the size, based on these parameters. What I'm going to do is this. So I'm going to do the same thing. So please, I'm going to override what was there before. If you want me to use z, I can use z. Okay, let me just equate it to a variable z now. So it's going to be normal, sorry, what am I doing? Random dot normal, yeah, what else again? So the first thing is your mean, right? So we talk about LOC. LOC is what we use, I think, if I can recall, it escaped me just now. Okay, limit of cover. I can't remember, but let me just check. LOC, please. LOC in statistics. Yeah, I just limit. Something like limit. It escaped me a little. So it's okay. Location parameter. Sorry, that location parameter. So that is LOC. So your LOC is actually mean. So your mean, which is, let me just make it within the middle point where the mean lies. Let me just give it a 1. Then your scale, the standard deviation is your scale. So let me put it in this place now. LOC, okay, LOC, okay. It's the same thing as mean. Standard deviation is also called scale in this case. So it's called scale, equals to scale. Let me just say scale. So we are going to use like 2 as the standard deviation. Okay, 2 left and right. Okay, size, the size of the entire stuff or distributions, let's say 10. Okay, let me just make it a single size, not 2-dimensional. So scale, so the scale is what? 2. Then the what again? Size. So I'm going to just give it a 10. Yeah, the size, sets of values. So I'll close it now. So please let me print z and be sure before we plot our chart. Z and be sure. Oh yeah, okay, so it's giving me stuff like so that's giving me, and these values are concentrated within what I've used parameters. The first one is scale, which is the deviations. Then the other one is your location. Talking about it, location, which is your main parameter. Then the size, which is 10. I'm not doing 2-dimensional arrangement or 2-dimensional values. Okay, now what is this? So we are going to plot this now. So it's SNS dot what? So distribution plot. So we're going to do this plot. We did this plot that time. This plot, distribution plot. What are we going to put there? So we want to just fix in everything here. So we want to plot based on distance. So we're going to copy. I'll just say, instead of copying everything, so let me just put Z here. Z. Then state a kind of chart there. It's KDE. If I don't put anything there, let's see. Let me just plot it and see plt.show. Please go through the previous video and you understand what I'm doing. So let me just run it. You see what's going to happen. So you have a lot of curves like this, which I don't want. I don't want. So that's why I'm going to give it a KDE, like the kind of chart probably. I want kernel density estimation, like KDE. I want it to be smooth, a curve to smoothing across. Or let me make. Can I make it 1000? I'm going to make it 1000. I'll change it later, but let me just finish what I'm doing. So kind. Let me just put kind is equals to KDE, kernel density estimation. So that we're smoothing the curve for us. So let's run it again and see what it gives us. So you can see the curve it gives us. Okay, I just want to show you how to draw this curve, normal curve with NumPy. Okay, so you can increase it to, let me just increase it to 1000. Run it, please. I don't want to print it because it print a whole lot of, 100 to print a whole lot of values, but no problem. So let's keep smoothing it more. I think let's now run this one now. See. Okay, so it's you can see the curve. So just go through this and try to understand in case we're going advanced in subsequent videos. So just understand the various parameter, how to generate normal sets of value for normal distribution curve, and then how to plot the curve using Seaborn. So thank you very much. I'm going to stop here right now so that you'll be able to digest it, go through video over and over, go through my previous videos, and then you'll get the reason behind what I'm doing. Thank you.